looked at this array that we started to create, and it's really nothing but a set of boxes. And it gives us one variable name, and we can put as many boxes inside of there as we want or we need. So if we have a store and we have a list of items for our store, I can put them all in there. And so if you can see this on some monitor, it's probably a good idea. I'm just going to fire up Excel. And to kind of show this idea of, slowly as Excel loads, that idea of these arrays again. And Excel is a great example of that. Let me see if I can make it a little bigger so it's easier to see. Maybe even a little bigger than that. So here we have our list of items. So it's one name. So let's call this items. And we know we're going to create an array. And so I'm just going to put in my square bracket. And I'm going to say I'm going to have 5 items. Our store is not very big. So those of you that work in retail, wouldn't it be great if you only had 5 items to deal with? Yeah. So up here, we're going to call these the subscripts. Or that index. You might also call it index. And so I want to put in that item, and I'm going to store all 5 of them, and I need that index for it. And so that index, remember that the computer starts at 0. And so that's one area we tend to, so I have 2, 3, 4, 5, 6. Whoa, wait a minute. How many did I say was in my subscript that I created? 5. So I better get rid of that one. Do I need to get rid of another one? Yeah. And that is one of the most common things that we're going to talk about, that keeping an array in check. So let's just put some items in here. I'm going to say milk, bread. What else might we find in a store? Eggs. If you went to the dollar store like I did last night, you had to get cat litter. Yay for kitties. So we have a few items in here. So we have 1, 2, 3, 4. Oh, so I can't count today. That's great. All right, there we go. I thought that looked weird. All right, cat litter. What else might we need? Coffee. So we have one variable called items. And that item stores a list or an array of items in there. And we address it. So if I want to figure out where eggs are, I address it as saying item. And that would be item 2. Milk, bread, eggs. Number 2, I think. So, yep. But in here, I'm addressing that it's that position here that's index is that. So it is the 3rd item in our array, but its index is 2. And that really is one of the hardest things to deal with, is making sure that we count in the right direction. That happens. We do it all the time. And one of the biggest issues we run into is we call it going out of our array. So I said, hey, we've got 5 items in our array. So I'm going to write a line that says, okay, I'm going to put in item 5 equals toast. And that makes sense, doesn't it? When you write it, you go, oh, yep, I made an array. I've got 5 items. I'm going to put in something into array item 5. But what really happens? Have we defined it? No. And in fact, some programming languages aren't going to care, and they're going to say, okay, we'll put something in here. We'll put a value in here. We'll put in toast. But what if this is part of another array already? So somebody else has already reserved that memory space, and now you've just written over the top of it. So that computer assigns these boxes. They're not unlimited numbers of boxes. And in fact, if you peeled apart your computer and you looked at it, it's a set of boxes from 0 to however much memory you have in your computer. And we arbitrarily break those up. So some gets used by the operating system, Some gets used by some of the programs. Some is used for storage. And so we have to be careful of staying inside this array. So inside the correct items we have in there. And this is the most common way we mess that up, is because our brains are going, yep, we got 5 items, click number 5. It happens. We all do it. So that's something to be aware of when we construct those arrays. So I know I can access any of these array items. I can grab it from any number, and I only have to deal with one variable name. So the other way I could have done this, if you want to think about it, I could have said item 1, item 2, item 3, item 4, item 5, and I could have made a list of individual variables. But the individual variables don't give me the ability to scroll through it very easily. I don't know how many variables I might need. What if I need 10? What if I need 10,000? This array I can build and have 10,000 items in it. But if I had to do 10,000 of these and try to keep track of all those individual variables, that's going to get pretty ugly. So we have our array now, and that's pretty handy. I can scroll through it. We know that I could do a for loop, and I could output everything on there. So if I did a really quick for loop, so let me just bring up a notepad really quickly, or as quickly as this computer is going to bring one up. Hello, notepad. There you are, way over there. Come here. Well, come this way. There we go. All right, so I don't really want to take up the whole screen with notepads. Let me drag it around. So I could do a for loop. And so for loops are something we just learned, right? They're pretty handy. They can say, you're going to do a loop of a definitive number of times. I know how big my array is, right? So I could do a for loop. So for I equals 1, 2. In this case, we're going to go 5, right? Or would it really be better to go 0 to 4? It's the same idea, right? If I did 1 to 5, I'm not going to get the right elements. So I indent and I say output items, and I'm going to put that little I in there. Normally I like my variables very, very detailed, but in this case, because we know we're using it for counter, a lot of times our for loops we use I's or J's or something, just because we're going to use it very quickly, very temporarily. And in this case, that would output everything that's listed inside of that array. So it would just create a list and go boop, spit them all out. If I can do that, it sets me up for the ability to search through that array and find specific items. And so that gets to be kind of an important item in here, is, hey, I can look through and I can find an item in there. So I can create a loop then. So I could say what I'm really looking for, because in here, up above, maybe you input choice. And notice I'm not going through all the declaring statements, so it's not a really great program yet, but I'm just adding some elements of it. So I'm going to input choice. And you're going to put in some value that hopefully matches one of these, right? And so now you're going to say, if choice is equal to item I, so we know an if then, so we have a then. So our indent, do what? Because I mistyped while I'm trying to talk. No. So items I, so as it scans through that list, so we output a list of them for whatever reason, just so as we know we can. Now we're just checking to see, hey, is this item available in our list? So if that choice is true, then we could output yes, we have your item. We could do an else, because we know that else would be the exact opposite of that, and they could output, we don't have your item. And you could do all kinds of other things, but this gives us a way to loop through and check every element in that array. That's a really good thing. We can do this in a couple of ways. And so if I'm really looping through there, the for loop works. I can do some other things with that. And one of the things I want to do is I know if I'm at this item, I want to exit out of my loop. And so there's a lot of different ways to do this. So we can add in a number into it. So we can add in a set value every time that will force us out of that loop. So if I add a value, so if my choice is found, I don't want to continue searching through that list of items. If you said what I wanted was milk, there's no sense to compare milk to bread, milk to eggs, milk to cat litter, milk to coffee. I want to exit out of that loop as quickly as possible. And so one of the ways we could do that is if that choice is true, not only do we say, yes, we have your item, but we change this value of I, because that I says 0 to 4, and as soon as it's over that value of 4, it's going to exit out of that loop. If we did a while loop, and maybe it makes more sense to explicitly say, while I less than 4, or whatever it is we're doing, or 5, and down in here we have, at the bottom of our statement, we have I equals I plus 1. So remember, we have to make some way to change that. So this is exactly the same, the output will be exactly the same. We've used two different ways to do it. So here we did a while statement. We did a for statement to do a definite number of loops. Either way works. But what we can add in here then is some way to say, you know what, we know that this loop is going to exit out of it as soon as it's above 5. I don't care if I goes way above 5. If I change this, and so add this, so the first time through it hits milk, it exits out of here because we had I is equal to 0 to start with. 0 is less than 5, right? I hope. It runs and it output all of our items, or output milk is actually the only thing that would output. If choice is equal to item, so my item 1 or 0 here, my first item in my list is milk, that's true, then it's going to output, yes, we have your item, and it's going to add a value of 5 to I. This else doesn't run because we didn't have it not true, and it comes back up to the top of that loop. Well, now I has changed. I went from 0 to 5. Is 5 less than 5? So it's exited out of that loop. Now, the only problem with this method is if I want to use that position indicator to then determine what that item is and use it again in the future, I don't have that value of I intact anymore, right? So often we do something like this. So we say found equals yes. Down here we just say found equals no. So that way, our found is automatically set to no. And up here, because we don't know what's in there, we're going to say found equals no, originally just ahead of the program. That way it's set to no going in there. Here's where we can can do something really powerful. So this way we can put in a compound condition. So while I is less than 5, so we know the number of terms, and found equals no, that loop will continue to run. As soon as we make that flip to yes, the next time through, that loop isn't going to run anymore, right? The advantage to that is then outside of my loop, I could then say, thank you for buying items. And you could still use that I. It didn't reset to 0. It's still got that same index in it. So in this case, it's got 0. And you're going to output, thank you for buying milk. So now we've got the way we can search through there. We can find a way to get an item and find its list. And the advantage, we keep that index value so I can use it later on. And it's going to become very important here in just a second, and I'll show you why. It's kind of handy to keep that item, that index, and use it in the future. And that's because I can actually do something called parallel arrays. And this is where we start getting some super powerful utility. What other things do we know about something in a grocery store? If I go pick up an item of milk, it's called milk. What else do we know about that milk? You do. That's a description. So each type of milk would be separate. But when I get up to the cash register, what do we know about that item? Price. So I could also say here I have an array of price, and I do the same number of array items, and so I could actually put a price in there, and I could say, what's a good price for milk? I buy it, but I don't pay any attention. $3.89. Bread, let's say $1.29. $1.89 for eggs. Wait a minute. $10.34. So we have a list of items now, and we put in a price. Oh, well, this might be handy, because now look what I can do. You just spent price I for and you'd have a sentence that said, you just spent $3.89 for milk. Because once I identified that item and I have that subscript, now I can reference that position and also reference something else about it. So I can use these parallel arrays to keep track of multiple items.
Okay, so you use I for milk, like it's like keeping that information, so you have to use a different variable for each one?
No. It's just, all it is a number, that 0 through 4 in this case, and we found which one had that value. And then once we did, so if we were looking for eggs, I would come through here and become 2 when it checked out. And we would say, all right, you just spent $1.89 for eggs. And it would be able to reference both pieces of those. So you could add other attributes if you really wanted to. So there might also be other attributes. So maybe there's a sale price, and not everything goes on sale. And you could attribute that as maybe that's $3.39, $1.19. Maybe this one never goes on sale. I buy at Shopko. It's okay. I know. Shopko's headed out of the business. So maybe you could have a sale price. And then you could say, not just you spent $3.89 for milk, but if you would have had the Saver card, you would have spent, and then I could say sale price, and I use that same variable, that index, because I haven't changed it. It's still set at whatever I find through this list, where that position is. And I know that's silly when we have 4 or 5 items, but we don't have to have. We could have 10,000 items in there, and it's going to work exactly the same. This is really the beginning of the idea of like a database. You're able to build and construct something where now you can retrieve items, search through that index, and this is really pretty powerful. Whether it's grades, whether it's items in a grocery store, maybe it's, personal accounting information, whatever it happens to be, we can actually search through there and we can find those items. We can find something that's equivalent to that. And so these arrays are kind of one of the most powerful structures we can build. Because with that, could we build a program without it? We could do item 1, item 2, item 3, and we could force our way through. We did a check on every one of them. This way, it's very contained. If I decided, you know what, we really have, instead of 5 items, I'm going to put 10,000 in there, this is what I can do. And quite frankly, this is what I would encourage when we write our code to do, is these mystery numbers, this 555, are kind of a mystery number. And so instead of writing it with a value in there, and I did that just to make sure we saw what was going on, I'm going to actually declare that array and putting in a variable. And so now when I declare, so size is equal to 10,000, now that variable comes in here, and I don't have just 0 through 4, I'd have 5, 6, 7. So I could have 10,000 items in every one of those arrays. My program doesn't change. So I notice here, I am going to have to change that, and I would say size equals whatever my value I picked over there, 10,000. So I can show you. So I less than, and now I just use that I less than size, and that's the only change I made. But it lets me programmatically change, and that's why we don't like those mystery numbers. So now I look up here and I go, yep, I have an array of 10,000 items. Oops, I mistyped. Oops, let me change that. I want 1,000 or 100 or whatever it is I have in there. I can change that. And when this program runs and it says, oh, I'm going to create an item, so I'm going to declare items size, that's when it says it sets up all those boxes. And your software says, I'm going to set up that number of boxes on that computer. We can also then put in all that information if we wanted to right here. So I could say items size, and I could say milk, and I could say bread, and I could put in eggs. So I could do it all in one step if I wanted to. I can do the same thing. So I'm going to declare price, and I could put in those values for that. 3.89, comma 1.29. I could also set them individually at any time. So if somewhere down in my program I want to change the price of milk, I could put in price, and I'm going to use a mystery number, so it's not good to do that, but just to illustrate, I'm going to put in 0, so that would be what my value is, equals milk shortage, so now milk is up to $4.99. And it's going to take whatever was in there, that $3.89, replace it with 489 is I can address each element individually. I don't have to go through and declare every item in that array. I can pick one item out. I can read one item. I can write an item. I don't need to do the entire list. And that's what's really powerful about those arrays. It gives us a way that we can do a lot of these things. If you look in your book, I forgot to open real quickly. So if I go to, probably have 30 copies of it on here, but if I look in our book and we go to, scroll down, and using a for loop. Chapter 5, sorry. Chapter 5. Chapter 5 arrays. So if I look at some of the programs in here, design the logic for a program that allows a user to enter 10 numbers, then displays them in the reverse order of their entered order. So we're going to look at number 1. We're going to build number 1 really quickly. So number 1 says, display the logic for a program that allows a user to enter. And I'm going to put it below here, just so you guys can keep that up on the screen for a little bit. So design the logic for a program that allows a user to enter 10 numbers. Well, that sounds like to me I've got a couple of things. So I'm going to make my area up here, and I'm going to go whack whack declarations, just so I know what's in this area. And the first thing I'm going to do, what size is our array? We know we're going to have an array. It says 10 numbers. So I'm going to put size equals 10. That just tells me I have a number in there. It's not going to change. It's a constant. We've capitalized it. And I'm going to put in a numeric value. So num. And what should we call our variable that allows a user to enter? Should we just call it user value? And remember, we're not just declaring an individual number, we're declaring that array. So I put in size. And so that just set up our array of 10 boxes. Do we have any data in there? We don't have a single piece of data in there. And we want to ask the user what those are. So I could say input user value 0. And I could put those all in and do it manually. Is there a better way we could do that? Yeah. Could we do it in a loop? And we know that for loop's kind of handy, so what if we did this? So what if we said for I equals 0 to 9? Is that 10 values? And then we just said, and remember we need to indent it so we know that's what's going to run in here. Input user value I. Now, I didn't get fancy and I didn't say, hey, attention users, please put it. I just said, here's a value, we're going to input it. So we are making this a little shorter than we could. All right. I'm going to eliminate my line there just because it bothers me. All right, so we get the user input. And we don't check even if they're valid numbers, anything. We just get a list of numbers, right? And the program then says, display them in the reverse order of what they put them in. So again, I could say, well, output user value, the highest one would be 9, right? So that'd be the last one they put in. And then I could say user value 8, user value 7. But the reality is, wouldn't I want to do this the same way I put the values in? So I could say for I equals 9 to 0, step minus 1. And all that's doing is saying it starts at a big number and it goes down So that program declares two variables. So size is equal to 10, and that's our constant. It says our numeric user value, we're going to put that in there. We take in those values, so it loops through 10 times, and then it outputs those values in reverse order. And all I did to change that reverse order was, instead of counting up, I used our for loop to count down. Wow. That's not that bad, is it? This makes a lot of really quick sense when we start looking at it, though. Let's see what time it is. 10:10. Okay. So we can look at some of these other programs that we're looking at here. Let me move this out of the way so I can pop the book up here. So what about this? So number 2, design the logic for a program that allows the user to enter 10 numbers, then displays each and its difference from the numeric average of the numbers. Oh. So now we have something a little harder. How do we calculate an average? Okay, so it's the sum of all the numbers divided by the total number of items, right? Okay, so in this case, whatever they enter in, we need to divide by 10, right? That's pretty easy. So, in fact, we have a value for 10 right there, divided by size. So we need another value in here. So what if we said num counter? And in this loop, when they're putting in values, we did this. So we said counter equals counter plus user value of I. So every time, so what's this doing is every time you put in a number, it's going to add it to that counter. So if you put in 10, it's going to say, all right, my first value is 0. So 0 plus 10 equals 10. I'm going to shove it into the counter. You put in a 10 for the second number, it's going to add it in. So at the end of that, counter then has a total of those values. That's pretty slick, isn't it? So it just adds it up. Just like if you're going to a grocery store, it totals up as you go through there. So now the problem then says, design the logic used to enter 10 numbers and displays each and its difference from the numeric average. So we maybe need to do a calculation. So we set up a value called average. How do we calculate average? So wouldn't it be counter divided by a variable we already have? And we know up here we really should declare num average. So now we have an average, and it says it wants to display every one of those numbers. How does it say it wants to display each number and its difference from the numeric average? Okay, so output user value, that part's still correct, isn't it? And then it wants to put in, so maybe we just put a comma, and we could output user value I minus average. So that would output the user value. So our first one would be 10. Maybe our average is 20, and it would actually subtract them and give you a difference between those. Now the only other thing, does it say to put them in reverse order? Does it say to put them in order? It doesn't really say if I looked at it right. Because it doesn't say, I would assume you'd want to put them in the same order. So we have to change this back to 0 to 9. And instead of step -1, it's step +1. Now notice up here I didn't put the +1 in because we just assumed. We really should probably say step +1 just to make it clear. But in a lot of languages we can get by with just having a I equals 0 to 9, and if you don't add anything, it automatically says, I know you want to go up by 1 each time. So part of these problems are determining what information is valid, what you need, and what you want for outputs. So your assignment this week, so the assignment this week, I guess I should probably go to the right week. Nope, week 5. I'm trying to jump ahead a week. So week 5 says, where's it at? At the end of the e-text chapter 5, please design the logic for 5b. Oh, 5b. Well, 5b is a little dangerous because when I look at it, where did I put my book? So 5b says, all right, modify exercise 5a. Oh, crap. So we have to find 5a to find 5b. Ooh. That's kind of tricky and sneaky. So 5a, let's take a look at it first. So 5b says modify it so the classroom's average of the test scores is displayed. Oh. Okay. We can do this. We just did an average. It's not that hard. And it says Watson Elementary School contains 30 classrooms numbered 1 through 30. Each classroom can contain any number of students up to 35. All right, so we have classrooms and we have students. So each classroom can have up to 35 students. Each student takes an achievement test and receives a score of 0 through 100. Write a program that accepts data for each student in the school, and it will take in their student ID, classroom number, and score on the achievement test. Design a program that lists the total points scored for each of the 30 classrooms. All right. So let's think about those items that we have and we know already. We know we have a school. Is the name Watson important in this? No. What is an important detail in there? So we have 30 classrooms. So I'm going to come down and just use this as kind of a running total. So we know I've got 30 classrooms. So sometimes it's helpful to write that out. I have 30 classrooms. How many students can we have in a classroom? So up to 35. Nowhere in there says it has all 35, right? That's a lot of people shoved in there. All right. Is there any other information we need that's going to be relevant in here? So we need to output. So student ID, or actually that's the input. I'm sorry. Input. Student ID. Classroom. Score. And total by classroom, isn't it? And total points. And that's total points per class or total points for the entire School of Watson? So that would be per classroom would need a total. Okay. So we have a little bit of digging to do and try to figure out what kind of things we need in here. So what kind of things could we do to start to think about that? We could go ahead, and so I'm just going to put in a start statement in here. And I always like to just make sure I put an and in. Start, stop, end, whichever one. And I want to look at those items that I'm going to need. And so sometimes it's easy enough to do. So we know we have a couple of them. So we know we're going to have, and it's probably a numeric, we know we're going to have this student ID. We know that we could declare something, the size, there is a hard number in there of how many classrooms there are, right? So that looks like a great thing we could possibly put in there. So size equals 30. Remember, those comments are free. You can put in lots of comments in there. So we know we have that. So what if we did, we know that we're looking for total points, right? So what if we declared something for total points? But are we looking at total for the school, or are we looking at total for each classroom? Each classroom. So what if we did this? So total points. And we don't have a value yet, so we don't know what we could do there. So we could set up that, and that kind of gives us an array of 30 boxes for the total points, right? So that gives us a little bit of a start. So we need to input, so you've got somebody in this office putting in data, right? So let's make our lives a little easier at the beginning of this. And let's do this. Let's use that, we call it the end of file structure. So that end of file structure, so rather than have to go through and fill in each one, let's just get a whole bunch of data in there. And let's do this. Let's create a loop. So we know we're going to input a couple of things. We're going to input student ID. We're also going to input then, so we have some number of classroom, okay? Did I declare a value for class number? So I probably need a couple of pieces up there. So let's do class number. So we can do that. We probably also need a numeric for a value we can add in there. I know we're going to need a counter at some point. All right, so class number, and we know we need that transient, the individual score. And we're not probably going to keep every individual score. We didn't create an array where we're going to keep a score of every student in there. We could, and there might be some utility to that, but we know that we're going to input. And we're going to call this kind of our priming the input, because we're going to create a loop. And so we're going to do our loop while not EOF. Yes. Yes, it should. So, input student ID, class number, and score. And so, we get in some value for a student ID, a class number, and a score. we're creating a loop. And so this is that priming input on our loop. And so we know that then inside of here, inside of there, we'll probably input that value again, right? Because we're going to have it inside of our loop. All right, so I think we have all our details. Let me see if I can make this any format. Okay, hang on a second. Chunk. Font. And I want to make that a little bigger just so we can see it easier. Is that easier to see now? Ah, okay. I can go probably up one more size and still have it all on the screen. I was squinting up here at this little monitor, so. Font. Let's go up to 18, see if that's big enough to read. All right. So, much better? All right. So, we're going to create this while not end of file. And so we know that anything inside of that then, anything inside of this loop has to be indented, right? So you nod and go, yup. Indenting is how we work that block. And so we have a couple of things we need to get out of that. So we probably should put a validation and all kinds of stuff, but for now, we're going to have a little bit of a different piece in there. And so let's put our input back in here. So it's inside of our loop. And indented. All right. So we know that we need to get that. We need to get it repeatedly. How are we going to score these things then and keep a score, a running score, every time we get a something in that class? So how are we going to keep track? We got student ID, class number, and score. So we have one called total points. So let's think about that between total points here and that array and that class number. What do the class numbers go from? So I'm just going to put a comment up here. Class numbers from 1 to 30. I created an array of size 30, but let me bring up this to see if that makes some sense. I'm going to delete this. And so here we have our class number. And so we have 1, we have 2, we have 3, 4, etc. Oh, you guys are onto this. All right. So my points, though, is an array, or total points I think I called it, is an array. And it says 30 in there. And so it actually indexes at 1, 2. So you are correct. We have to do a little bit of manipulation so that when they put in class number, we are getting the correct one. So on top of this, and we'll show you why, we're going to start adding up those points in that. And so we're going to say total points. And here's where it's tricky, or one way we could do it. There's a lot of ways we could do it. So we want that total points, but we don't want just class number. We want class number minus 1. Does that make sense? We're shifting it from the way we count to the way the computer counts. And we're going to say equals to. Now, here's where that copy and paste comes in handy. I'm going to copy this. And I'm going to paste it. Plus score. So, think about what's happening here. We input their student ID. Now, are we really doing anything at this point with that student ID? No, we're actually not. But we say input student ID, class number, and score. So they put in their class number. we flip that to that index number, so we have to subtract 1. And so as this program loops through over and over and over again, so the first time's that priming input, it takes this value and puts it into that particular item. And so this will loop until all that data is processed. So, bless you. So at the end of this, at the end of that loop, what do we have? Do we have a total then? Is total points for each one of those classrooms? Is it added it up for us? Yeah, that's a pretty slick way to do it. So now we have to get out that output. So here's where it gets a little trickier, because we added one before. Now maybe we need to subtract one when we start thinking about this. So we're going to output, and our output probably is going to need to be a loop, right? So I might just use a for loop for I equals, and we know it's 0 to size, right? And so you're going to output, and you're going to say this is class room number, and you're not going to put out just I, you're going to put I plus 1, right? So the first time this loops through, it's going to say class number 1, output total points. Now, do I need to do anything with I in this case? So we put them back together, and that's where this gets tricky with these. So that's going to loop through and output class number. It's going to output the total points for that class. Well, that's pretty clever. That's pretty clever. Now, is that the prettiest thing in the world? Yeah, it's kind of clever and slick. Look how quickly we can take that data and we can put it in there. Now, are there other things we could do? Could we validate that input so that we know that it's actually the right classrooms? So if somebody tried to put in classroom 32, yeah. Or if a test score is above 100, could we validate that information? Yes. Should we validate it? Yes. But right now, as a bare bones, this gets our data in, and as long as that person typing in data doesn't make a mistake, does that give us the total number of points for every classroom? It does. Or it can. So, part B then. Yeah, I need to. Sorry. End while. So, part B then says that produces a count. Oh, nope, wrong one. Wrong B. Design a program that accepts. Nope. 5. Gosh dang it. I'll find the right one here eventually. So you're going to modify it so it gives you the classroom average of the test scored rather than the total. All right. So that becomes a little trickier though. And here's why. In our program up here, where we look at it says each classroom contains any number of students up to 35. It does not say that it always has 35. So now, to get an average, you've got a total by every class, but you're going to have to try to figure out how many students there are in each class. So you're going to have to add in another counter of some sort to count the number of times that a classroom is referenced. Does that make sense? So every time that this goes through this and says, I have classroom 1, that it adds a counter in there for classroom 1. And so you can tell how many students there are. So you're really going to need, I'll give you a hint here. So you could say students by class, class student. And you're going to have to do another array. So that other array now, so not only do you have this data, so you have the class number in an array, you're now also going to have some way to every time it gets a certain class, add a value into that. So you can keep track of how many students there are in each class. So you're going to have another array, and in this case we called it students by class. You could call it whatever you wanted to. And so you're going to output then at the end, so class total points, and you're going to output the average, which would be then total points of a particular classroom divided by the student by class So somehow you're going to have to figure out a way to count every time we get a student that goes through there.
So for the array, can you have both of them say size? Like would that mess with things?
No, size size is just a value we put in there of 30. So it's convenient for us to have that.
Okay, but the student, do we have to define another size then as up to 35? Because the students can go to 35 instead of just 30?
No, because what you're doing with size is you're saying you're creating 30 buckets. So maybe it'll make more sense if let me put it over here. So you have a couple of arrays in here. So your first array is, which one are we doing? Total points. So you have one called total points. I'm just going to shortcut it to total. And it's got 30 buckets. We said it's 30 items in there. So this is classroom 0, classroom 1, classroom 2. That we know we need to translate by 1, right?
Yep. So
you're also then saying, then this is the student count. Maybe student count is better. And you have 30 buckets in there because you need to figure out how many students are in each class. So maybe class 1 has 5, this class has 35, this one has 30. So you have to figure out the number of students.
in relation to the economic class.
Correct. So you're trying to count those as they go through there. So you're getting that data. You're getting the input of the student ID, the class number, and the score. So somehow in here, you need to figure out how to add a value in every time you reference a class number. So that is kind of a little tricky. That is a part that's going to pull out your hair a little bit. You can do it. I know everybody can. You just have to put the thinking caps on and think, how can I add something? So I will give you a hint. It's not adding the score. So this piece at the end where you're going to add something, you're going to add +1, right? Because you're going to loop it through. But every time you reference a particular classroom, you need to add a counter to add 1 to that. And then at the end, you can output all different kinds of stuff. So here, we output it all together. You could even output and go through and add them all together and do some other things to see how big the school is in total. All right, so really quickly, I want to look at one more item here. So So because I want to show you what this language looks like, and I already showed you how to install, and we'll go through that a couple more times, make sure you have somewhere that you have Python installed. So I will create a separate just install video. But here is, over in the other screen, slowly, this is, remember our little program from last week that we were supposed to create. So I rewrote it really quickly to run in Python. And Python does a couple of things, and each language has some peculiarities. And of course, remember when I said, you know, if you're going to have to declare this as a numeric or as a, and notice I don't have that in here, right? I just say months equals 12, years equals 30. I have my message, and I don't have to declare it as a string or a numeric. Python is really easy and just loves us, so it doesn't even make us do that. I just declared a variable and assigned a value to it, and it lets me do that. Other languages, we have to tell it explicitly what we're going to use. And it also leads to some problems with Python because we do have different types of data in there. So this is that same program. So month counter equals 1, year counter equals 1. Here's our outside loop. And so the other part, notice, does it explicitly have an end while? No. It does that all based on when you come back on the indents. And so when I yell about making sure you do the indents, that's part of the reason why. And so it's got an outer loop. It's got this inner loop. So year counter, month counter. So this inside loop, print month counter, year counter, and message. That output, and one of the things I saw was people put that outside of that inner loop. It has to be in that inside loop because it's the piece you want to run 360 times. Here we say month counter equals month counter plus 1. In other words, we add a value once a month. We have a month counter equals 1. That allows it to reset. Once it goes through 0 through 12, it resets back to 1 again for the next year. And so if I actually run this, put it in this screen so you can see what it's doing. So if I think about what my output should have been, this didn't do anything very exciting. That message isn't really creative. So it says output month counter, so 12. In this case, that would be your last payment. And the year counter, so 30 years. And that message, remember to allow 5 days for mailing. And so if I scroll all the way up, there should be 360 of those little messages that popped up. So here it says month 1, year 1. Now, I could change that if we really wanted to. You could change this and add it so it would display the actual year or the actual month or date or different things. All we're looking for is, do you have that ability to run those inner and outer loops? And notice, like I said, it doesn't have an explicit end while. So I like to make sure we put them in there just so you see what they are and how you can do that. But everything inside of Python is based on the idea of those indentations. So that's what we're actually going to start building and what you're going to look at. So this is, when I run this program, that's what it looks like as it runs. And it scrolls through those 360 items right there. If I change this or I forget something, so for example, if I didn't put this statement in right here, month counter equals 1 to reset. When I don't reset it, it runs through all the months and it gets stuck at year 1. Because we don't have that ability to flip over and reset. Because it's only going to run that particular thing once. So that's what we're headed to. That's what we're going to look at. So make sure you've installed that. Work on this homework. And you can certainly add to it, clean it up, make it look really nice and pretty. So you could put in tests. So you could make a test to say, you know, and our book talks a lot about doing like a while loop. While class, number is less than 0 or greater than 30, then we know we have to get a different input, right? If they had, so we could verify and validate those inputs. And that's something we're going to work on a lot when we get into Python also. But if you can figure out this piece, that's kind of that structure I'm looking for. How to use those arrays, how to use parallel arrays, and how to use them. So we're going to hit those really hard. All right, any questions, guys?